Dear students, we are solving the IB Math A HL past paper questions, and currently we are solving the IB Math A HL May 2021 paper 1 time zone 1 past paper. And today we will be solving question number 11. We are solving one question every day, and it is a paper 1. Therefore, we will not be allowed to use the calculator, and you will be getting the links to all the previously solved questions in the playlist given in the description area. So, question number 11, and it contains 19 marks, and it says, consider the line L1 defined by the Cartesian equation x plus 1 over 2 equal to y equal to 3 minus z. So, L1 is having this equation, and subpart A contains further two subparts I and II. I says, show that the point -1, 0, 3 lies on the line L1. Okay, so the line L1 is having, it is a line, so it is definitely having infinite number of points on it, and the coordinates of the points will be x, y, z, of course, where x, y, and z values will be different for different points. But the relation that has been given by this x plus 1 over 2 equal to y equal to 3 minus z will be satisfied for every point on the line. X plus 1 over 2 value may be different for different points. It may be x plus 1 equal to 10, y equal to 10, and 3 minus z equal to 10. All three of them are equal to 10 each. And or it may be x plus 1 over 2 equal to -1, y equal to -1, 3 minus z equal to -1. The value may be different for different points, but whatever value we get for the expressions given in this relation, I'm calling this as a relation rather than as an equation, because it actually contains three equations. It is the Cartesian equation of a line, but we can just decompose this into three equations: x plus 1 over 2 equal to y, x plus 1 over 2 equal to 3 minus z, and y equal to 3 minus z. So, depending on which point we are taking, the x plus 1 over 2 value or the y value or the 3 minus z value will be different. But they will be equal to each other for every point on the line. Okay. So, if this point -1, 0, 3 lies on the line L1, whose Cartesian equation is given to us, then on substituting -1 for x, 0 for y, and 3 for z, we should be having this relation satisfied. Let us see whether we get the same value for x plus 1 over 2 and y and 3 minus z on substituting these numbers. So what is the value of x plus 1 over 2? When x equal to -1, x plus 1 over 2 is equal to -1 plus 1 over 2. -1 plus 1 is 0. So 0 over 2 is 0. So this is 0. Okay. So x plus 1 over 2 is equal to 0 when x equal to -1. When y equal to 0. Y equal to 0, and the equation is also having only a single y. So x plus 1 over 2 is equal to 0 and y is equal to 0. They match. Fine. So when c equal to 3, then 3 minus z should be equal to 3 minus 3, which is equal to 0. So each of these three parts is equal to 0. Therefore, this point is satisfying this given relation or this Cartesian equation. Hence, -1, 0, 3 point lies on the line. Since x plus 1 over 2 equal to y equal to 3 minus z, when x equal to -1, y equal to 0, and z equal to 3. Therefore, the point -1, 0, 3 lies on L1. Okay, so this was actually the answer to subpart AI. Okay, so we have shown that this point does lie on the line L1. Coming to II, find a vector equation of L1. Okay, vector equation of L1. So let me just write this Cartesian equation given to us over here. X plus 1 over 2 equal to y equal to 3 minus z. Let this be equal to some parameter lambda. Lambda is a real number. Okay. And now I should be continuing down because I don't have any more space. So I come to this point over here. This is AII continued. So x plus 1 over 2 equal to lambda. X plus 1 over 2 equal to lambda. Y is equal to lambda. Y is equal to lambda, and 3 minus z is also equal to lambda. Yeah? Therefore, what can we get? We can get the xyz expressions. X will be equal to 2 lambda minus 1, which can be written as -1 plus 2 lambda. Actually, we write the number first. So -1 plus 2 lambda. Y equal to lambda, this means y equal to 0 plus lambda. Lambda or 1 lambda, anything. Not write 1 explicitly. If it is lambda, obviously it is 1 lambda. Okay? And z will be equal to 3 minus lambda or 1 lambda. Okay? Therefore, the vector equation of L1 is R. R is the position vector of any point on the line L1. So this is equal to x, y, and z, which is equal to, we will be taking the numbers first. Actually, this is the point on the line. This is the point on the line that we know. There are so many, there are infinite number of points on the line L1, but we know that this point is on the line for sure. And this we have just now tested in the AI part, that this point indeed lies on the line L1. Okay, it is the same point that we are getting. So it is -1, 0, and 3 plus the parameter lambda times It is 2 lambda, so it is 2. And then 1 lambda 1 and minus 1 lambda minus 1. This is the direction vector of the line L1. The line L1 is in this direction. In this direction or in the opposite direction, but it is parallel to this direction vector. Okay. So we have given the answer for AII. Okay, so this is a part B. It says consider a second line L2 defined by the vector equation R equal to 0, 1, 2 plus T, A1 and negative 1. This is the actually direction vector of L2, where T is a real number and A is also a real number. Subpart B says find the possible values of E when the acute angle between L1 and L2 is 45 degrees. It contains 8 marks. Okay. So the direction vector of L1, maybe L1 is in this direction and L2 is in this direction. I'm drawing arbitrary lines. Maybe this is L1 and this is L2. The L2 is almost a horizontal line. These are not authentic lines, the L1 and L2. I don't think they are having these directions. I've just drawn two arbitrary lines. So now, and I have drawn two intersecting lines because they have said that the possible values of A have to be found when there is the acute angle between these two lines. The acute angle is 45 degrees. Since there is the acute angle, that means the lines are intersecting. You cannot have an acute angle for two parallel lines. So they are intersecting. That means, okay. So the angle between two lines is in fact the angle between the two direction vectors, because the direction vectors show the direction of the two lines. Okay. So this is the direction vector. Let us write the direction vectors. For the L1, it is 2, 1 and negative 1. So let me write the direction vector of the line L1. Again, I am showing 2, 1 and negative 1. 2, 1, negative 1. And direction vector of the line D2, L2 rather, is D2 I am taking, and it is E1 and negative 1. Okay. And one thing that I am seeing just from these two direction vectors, as soon as I have written these two direction vectors, the first thing that is becoming so very conspicuous and so very prominent is to me is that, you see, this is 1, this is 1. This is -1, this is -1. Only this one is 2 and this one is a variable A. If A is equal to 2, then D1 will be equal to D2. Okay, the direction of the two lines will be the same. That means the direction of two lines are the same, means the two lines will be parallel or they will be coincident. Okay, but the two lines are not parallel. If the two lines are parallel, then you will not be having an acute angle between them, and they are not coincident as well. In that case, you will not be having an acute angle in that between them. Okay, so the first thing that is coming to my mind is A, it is a variable, and they are saying find the possible values of A. I can straight away say that A cannot be equal to 2. Because if A is equal to 2, then the two lines will be parallel. So they will not be intersecting. So this is the first thing that is coming to my mind. Well, I have to get the actual values of A. For that, let us use the dot product or the scalar product. As I have said, the angle between the two lines will be the angle between the two direction vectors of the two lines. So let us do the dot product or the scalar product of these two lines, direction vectors of these two lines rather. So D1 dot D2 is equal to 2 times A, is 2A, plus 1 times 1 is 1. Okay, let me write 1 cross 1. Plus negative 1 times negative 1, which is also equal to 1. So it is 2A plus 1 plus 1, which is 2A plus 2. Okay, I can take this as 2A plus 1 as well. You may keep it as 2A plus 2. Fine. Now we get the modulus. Should be equal to 2 square plus 1 square plus negative 1 whole square. This is the square root 4 plus 1 plus 1 equal to square root of 6. What about D2? Modulus of D2 will be equal to square root of A square plus 1 square plus negative 1 whole square is equal to A square plus 1 is 2. Okay. So now we are in a position to write the equation. D1 dot D2 should be equal to modulus of D1 times modulus of D2 times cos theta, where theta is the angle between these two vectors, the direction vectors, or between the two lines. So now I'll just be substituting the values. First is D1 dot D2, it is 2 times A plus 1. So 2 times A plus 1 equal to, this one is modulus of D1 is root 6. Modulus of D2 is A square plus 2 square root, of course. And cos theta, theta was equal to 45 degrees. Showing you again the angle, it is 45 degrees. So cos 45 degrees. And cos 45 degrees is equal to 1 over root 2. I'm not doing the rationalization to write 2 over 2. I'm keeping it as 1 over root 2. Rather, I am writing root 6 as root 2 times root 3. You don't do the rationalization every time, because you make the, if you don't do that, you may be in a better position. So this will be 1 over root 2 and these two will be getting cancelled. Okay. So that is why I had said that don't go for rationalization every time. And so it is, let me write the equation once more. 2a plus 1 equal to root 3 times root a square plus 2. Okay? And we have to solve this equation in order to get the values of a. Therefore, we have to square both the sides in order to get rid of these radical signs. So this will be, okay, let me write it this way. 2 times a plus 1 whole square is equal to 3 a square plus 2. And what is this equal to? 2 square is 4. A plus 1 whole square will be a square plus 2a plus 1 equal to 3a square plus 6. Okay. This is a quadratic equation. The variable is a, so it will be 4a square minus 3a square plus 8a plus 4 minus 6 is equal to 0, or a square plus 8a minus 2 is equal to 0. So I don't think I can factorize this expression, hence I have to go for the quadratic formula. A is equal to minus b, so it is minus 8 plus minus under root b square, that is 64, 8 square is 64, minus 4 times 4ac, so 4 times 1 times c is negative 2 over 2a. So this is minus 8 plus minus under root. This is negative 4 times negative 2 is positive 8. 64 plus 8 is 72. Over 2. Okay, so let us see if we can verify that third part. Plus minus 72 is 36 times 2. And what is 36? I can write it as 6 times 6, or I prefer to write it as 4 times 9 because both of them are perfect square and this is the square root. So this will be 4 times 9, that is 36 times 2 over 2. So this is minus 8 plus minus. From this 4, 1, 2 will be coming out, and from this 9, another 3 will be coming out. So 2 times 3 is 6. Okay, sorry. It was 36, so 6 times 6 is 36. 1 6 could have come out. Yeah. So this is this. And therefore, the A value is equal to minus 4 plus minus 8 over 2 is 4 and 6 over 2 is 3. So the A value is either minus 4 plus 3 root 2 or minus 4 minus 3 root 2. So we have completed subpart B. So this is subpart C. It is given that the lines L1 and L2 have a unique point of intersection A. They have to have a unique point of intersection, because in the previous subpart they say that they are intersecting at an angle 45 degrees. 45 degrees means if this is 45 degrees, this is an acute angle, this has to be an obtuse angle. Okay, so this has to be 135 degrees. But we have taken the acute angle. So they are intersecting at a point, otherwise they could not have intersected at an angle of 45 degrees. In subpart C, you cannot take the condition that they have given in subpart B, that they are intersecting at an angle of 45 degrees. We do not know. They may be, they may not be. Most probably they are intersecting, but that depends. What is the A value? That depends on the A value. So we are not sure of the angle. So don't take that they are intersecting at 45 degrees. That is not sure. But what is sure is the equations of the two lines. Because the lines are the same, therefore their equations will be the same. A may not have the same value as we had found the two values of A in the subpart B. A may not be having any of those two values. A may be having completely a different value. So they may be different, intersecting at a completely different angle. That is possible. But the lines, the direction vector, the equations of the lines and the direction vectors of the lines, they remain the same. So they are saying that these two lines intersect at point A. So this one is point A. When A is not equal to K, is over here, A is not equal to K, subpart C, find the value of K and find the coordinates of the point A in terms of point capital A in terms of small a. It contains 7 marks. Okay. In terms of A, because we should not be taking the previous values that we have found for A. A can have completely a different value. So what we can do is, what I think is to just say that A cannot be equal to K and find the value of K. The easiest way for getting the value of K will be, because the vector equations remain the same for these two lines and the direction vectors also remain the same, because the lines are the same, the direction vectors should also be the same. Okay. So therefore, as we had written before, D1 is equal to 2, 1 and minus 1, and D2 is equal to A1 and minus 1. Therefore, and as I had said while solving the subpart B, that when A is equal to 2, D1 becomes equal to D2. That means the two direction vectors become the same, which implies that L1 is parallel to L2 or coincident to L2. Because if they are parallel or they are coincident line, obviously they will not be intersecting at a unique point. Coincident lines means one is on top of the other. You don't have separate entities. They both make the same line. Okay. So they are intersecting at infinite number of points. You don't have a single point of intersection for them. And when they are two parallel lines, you don't have any point of intersection between. Because the question says that the two lines are intersecting at a single point, Therefore, A cannot be equal to 2. They are asking for the value of A which it cannot take. A is not equal to K, and what is the value of K? That is the question. So let us write it this way. If from the direction vectors we find that if A is equal to 2, then D1 is equal to D2. Okay? Which implies that either L1 is parallel to L2 or L1 and L2 are coincident lines. Means it may be that one is in this direction, but that also you cannot well, you may consider that way. One is in this direction and the other is in this direction. That may be taken, but they will be on one on top of the other if they are coincident. And if they are parallel, they may be having the same direction or they may be having the opposite direction, but they will not be intersecting at any point. Okay? So either L1 is parallel to L2 or L1 and L2 are coincident lines. Okay, full stop. But in neither of the two cases, do the lines L1 and L2 intersect at a single point. Therefore, A is not equal to 2. So, A is equal to 2. Because in the question it is A is not equal to K and find the value of K. Therefore, A is not equal to 2. Hence, K is equal to 2. Okay? This is one part of subpart C, and they are saying find the coordinates of the point capital A in terms of small a. Okay. So, as I've said, this is the position vector of a general point, an arbitrary point of on line 1. So, an arbitrary point having coordinates x, y, z. And x will be equal to what? -1 plus 2 lambda. Y will be equal to what? 0 plus lambda, that is lambda. And z will be equal to what? 3 minus lambda. So this is, and obviously the lambda values will be changing from point to points. Therefore, you will be having different points for different values of lambda. But the expressions should remain the same. They will be 1 plus or minus 1 plus 2 lambda, lambda and 3 minus lambda. This is for L1. And what are the coordinates of the point of any point of L2? 0 plus 80, that is 80, 1 plus t, and 2 minus t. Okay. Again, depending on what value of t are we having, we will be getting different points on the line L2. Okay. So these are the coordinates of a line of a point on L1, and these are the coordinates of a point on L2. And when they intersect, when the two lines intersect, the coordinates will be the same. That means the x-coordinate is given by this expression minus 1 plus 2 lambda, and the x-coordinate is given by this expression as well, 80. So these two should be the same because the coordinates of the intersecting point should be lying, is the point, the intersecting point is on both L1 and L2. Okay, so the coordinates of that intersecting point will be satisfying line L1 and will be satisfying line L2. So we will be now equating the XYZ coordinates from the two lines. Okay, let me just write, first of all, minus 1 plus 2 lambda equal to 80. I'm not sure whether you'll be able to two position parts together. So minus 1 plus 2 lambda equal to 80. Minus 1 plus 2 lambda equal to 80. Lambda equal to 1 plus t. And t minus lambda equal to 2 minus t. Three minus lambda equal to 2 minus t. And they have asked us to get the coordinates of the intersecting point in terms of small a. Therefore, small a is only in the equation 1. So let us take the first two equations. Okay? So lambda equal to 1 plus t, let us substitute this expression in this equation. So it is minus 1 plus 2, 1 plus t equal to 80. Or minus 1 plus 2 plus 2 equal to 80. And 1 plus 2t equal to 80. I can write 80 minus 2t equal to 1. I'm taking all the terms containing t to one side. So I can take t common. A minus 2 is equal to 1, or t is equal to 1 over a minus 2. See, even from this expression of t, you are seeing that a cannot be equal to 2 because you cannot have a 0 in the denominator. So even from this way, if you don't go for the direction vectors, you can see in any case you have to get the coordinates of the intersecting point. So you have to come to this part. And over here also we are seeing that since the denominator cannot be equal to 0. Therefore, A cannot be equal to 2. Okay. And we have got the value of t in terms of A. So now we are in a position to get the coordinates of the intersecting point. Since I have got the expression of t, value of t or expression of t in terms of A, I'll be taking these coordinates rather taking these. Okay? Because both refer to the same point. So it will be AT, this is point A. AT 1 plus t and 2 minus t. A times 1 minus 1 over A minus 1 plus 1 over A minus 2, 2 minus 1 over A minus 2. This one is A over A minus 2. This is A minus 2 and A minus 2 plus 1. And that one is 2A minus 4 minus 1 over A minus 2. Therefore, coordinates of point A will be A over A minus 2. This is minus 2 plus 1 is minus 1. A minus 1 over A minus 2. 2A minus 4 minus 1 is minus 5. 2A minus 5 over A minus 2. Okay? So we have completely solved the subpart C as well. Yeah, we have given the coordinates of the point A. So this completes question number 11, and we have solved the whole question. But if you're wondering that who am I am Nilanjana Sanyal. I tutor students of IB Math A, SL and HL. And I have planned to start online group math tutoring sessions for IB Math A, SL and HL students from this month of July. So if you are interested, if you can see the email ID and the WhatsApp number getting displayed. You may mail me, you may text me. If you want to join my classes, you may contact me this way. Okay? And thank you for staying with me till the end. And we meet again tomorrow with question number 12. We will be solving question number 12. That will be the last question of this paper. So till then, bye.